we are talking about the second law of thermodynamics. So in this beautiful subject of thermodynamics, I myself Shivam Dixit welcoming you all. 𝐂𝐤𝐧𝐤𝐬 is here, Arsh is here, and Sujata Yadav is here. So very good evening and very warm welcome. Okay. Welcoming you all. Okay. So I hope it is audio, video, everything is fine. Just let me know once. Audio, video, everything is fine. So we have already studied the first law of thermodynamics. The very first question coming in our mind, that what is the problem with first law of thermodynamics? Why second law of thermodynamics exactly needed? So first of all, I would like to tell you here, there is no any fault in first law of thermodynamics. There is no any problem with first law of thermodynamics, because in laws, if there is any problem, if there is any problem, then it will not hold good, right? If it is not holding good, then it is not even law. So basically there is no problem with first law of thermodynamics. First law of thermodynamics simply says that energy is conserved. Energy is conserved during the cycle or a process, and energy balance hold good. But problem is, it does not tell us about like what is the direction for a particular process, whether the system is feasible or not, right? So first law is not giving you the clarity about the feasibility of the system, not giving the direction for a particular process, not talking about the quality of energy. Means if you have 100 kilojoule of heat, 100 kilojoule of work, so as per the first law of thermodynamics, both are exactly same. The reason is very much simple, because it is a quantitative law of energy, right? Quantity, it only talk about the quantity of energy, right? But second law of thermodynamics will give you the clear idea whether the system is feasible or not. System is feasible or not, and it will give you an idea that what could be the direction for a particular process, and what about the quality of energy. So all these things are given by nothing but a second law of thermodynamics. Hello Hemu, hello. So Hemu is saying that I am a new student. No problem, you can continue from here, no issue at all. If you are little bit okay with first law of thermodynamics, or you can go to the previous lecture and attend, right? It's your wish. Okay, so now in this chapter, what we are going to talk about, in this chapter we are going to talk about one part of the second law of thermodynamics. Please listen here carefully. Here we are going to talk about the first part of second law of thermodynamics, that is second law of thermodynamics for cycle. After this we will talk about second law of thermodynamics for process, and that is nothing but entropy chapter. So basically this chapter is going to be covered in 2 lectures. Names are different, right? So the first lecture is basically the second law of thermodynamics for cycle, which is I'm going to talk today itself. Now voice is okay. Now I think it is okay, right? Now I think it is okay. Okay, okay, okay. Very good, very good. It means so much students are there. When I am asking any question, then you people are not replying. When it is muted somehow, like battery is actually discharged, right? So you people are no audio sir, no audio sir, no audio sir. पता नहीं कहाँ से आ जाते इतने सारे लोग हैं, और जब मैं ऐसे क्वेश्चन पूछता हूँ तो कोई नहीं बोलेगा सर आई डोंट नो. Okay, so these concepts are like, in which this is the most important one, Clausius inequality, right? Majority questions are going to be asked by the Clausius inequality only. Okay, fine. So shall we move, right? Okay, so first I am going to tell you the heat engine, refrigerator and heat pump concept, how these things are come into the picture. So the second law of thermodynamics, first initially the first law of thermodynamics is given by none other than Joule, right? Joule sir have given the first law of thermodynamics. Sorry, first law also Joule only given, second law also given by the Joule for a cycle. So what he told that for a cycle, right? For a cycle, work can be completely converted into the heat. Work can be completely converted into the heat, but complete conversion of heat into work is not possible, right? So basically Joule have given this statement, and the important part is that the heat cannot complete amount, it is not possible to convert complete amount of heat into complete amount of work in a cycle. Not process, it is possible. Process it is possible. For a cycle it is not possible. For a cycle it is not possible. So complete conversion of low grade energy, that is heat, into high grade energy, that is work, is not possible. Okay sir, no problem. Then but he is not, like I'm talking about Joule. So Joule have given this statement that complete conversion of low grade energy into high grade energy, low grade energy means heat, into high grade energy means work, is not possible for a cycle. But he is not able to explain what is the significance of this particular statement. Then after that one person came, the name is Kelvin Planck. The name is Kelvin Planck, right? Kelvin Planck said that it is impossible to construct a device. Please listen here carefully. It is impossible to construct a device. Suppose this is a device. It is impossible to construct a device which produce work continuously. Now, if work is produced continuously, right? If work is produced continuously means it is going to operate on the cycle, obviously. It is going to operate on the cycle. Okay. While exchanging heat with a single reservoir. Means, let's say this is a Q in I'm writing from temperature TH. So he said that this type of device is not possible, because this device is going to do what? Complete amount of heat is going to convert into complete amount of work. No amount of heat is going to be rejected, and this device is called as PMM2. Perpetual motion machine of kind 2. This kind of device is not possible where there is no any heat rejection. Just a minute please. So here there is no any heat rejection. Now then he told that this device is not possible. It is not possible to construct a device which produce work continuously while exchanging heat with a single reservoir. But if you are ready to exchange heat with multiple reservoirs, minimum 2 reservoirs, means you are ready to reject some amount of heat, then it is possible. And this device is called as what? Heat engine. Then this device is called as heat engine. And the performance, to measure the performance of this engine, efficiency is given as work output by Q input, or I can say that work output is basically Q in minus QR. Like whatever heat is input, whatever heat rejected, the net work is output, right? So this can be written as 1 minus QR by Qn. Now this is valid for reversible as well as irreversible engine. Valid for reversible and irreversible both. Valid for reversible and irreversible both. So this is basically the concept of heat engine. Now again I am going to repeat, the first law does not have any problem, but it does not give any information regarding the feasibility of a system, direction for a process, quality of the energy, because it is a qualitative law of energy. So second law of thermodynamics will tell you the feasibility of a system, direction for a process, that's why it is called as directional law, and it talk about the quality of energy also, that's why it is called as qualitative law of energy. Then first the second law of thermodynamics is given by Joule, and Joule sir have said that complete conversion of low grade energy means heat into high grade energy, that is work, is not possible for a cycle. But he is not able to tell the significances. Then Clausius, like Calvin Planck came. Calvin Planck said that it is Calvin Planck said that it is not possible to construct a device which produce work while exchanging heat with a single reservoir. So obviously if you want to produce work for a cycle, then multiple reservoirs are required, then heat must be rejected. Then this is the efficiency formula. Correct? Right. Now सर ये पीएमएम पढ़ाते टाइम तो अच्छे समझ में आता है, सीक्वेंस में याद नहीं रहता. Only 3 PMMs are there, PMM1, PMM2, PMM3. Just remember, like PMM1 is regarding the first law of thermodynamics, PMM2 is regarding the second law of thermodynamics, PMM3 is regarding the reversible process. Okay, so you need to write beta. See, I completely agree with you that today you are able to understand, but after few months you will forget all these things, right? But if you write somewhere, then it will take hardly few minutes to revise. Now after that, one more person came into the picture. Name is Clausius. So Clausius said that it is impossible to construct a device. It is impossible to construct a device which operate on a cycle and transfer heat from low temperature body to high temperature body without any external energy input, TLH, right? So now this device is not possible as per the Calvin Planck, without external energy input. So sir, how to produce very low temperature, how to produce temperature less than surrounding temperature? Very simple, you need to supply the work. So if you are ready to supply the work, right, work input, then it is possible. Now this device is called as refrigerator. So I would tell you, like, what is refrigerator basically? Refrigerator is a device. Let's say this is your room, right? Just assume that this is your room, my dear student friend. Now you want to create temperature less than surrounding temperature, means TL must be less than T atmospheric, right? So if you want to produce, suppose it is a summer season, outside temperature is 40-degree temperature, and you want to maintain in your room, this is your room, and you want to maintain 20 degrees centigrade. So to maintain 20 degrees centigrade continuously, you need to extract heat from here, and the amount of, please listen here carefully, the amount of heat which is to be extracted, from the storage space in order to maintain it at lower temperature, is known as refrigeration effect, right? Okay, very good. So this is basically refrigeration effect, and this is basically QH minus QL, right? Here I will write that is equals to QH minus QL. Clear? So this is the basically work input required. Now this device is called as what? Refrigerator. This device is called as a refrigerator. And to measure the performance of refrigerator is measured as refrigeration effect by W input, or I can say refrigeration is QL, W input is QH minus QL. This is also valid for reversible as well as irreversible refrigerator. This is also valid for reversible as well as irreversible refrigerator. Any problem? I hope there is no problem at all. Now let me consider the similar case, one more similar case. For example, now it is a winter condition. बहुत ठंडी है, right? Now it is a winter situation. Assume that is a winter. This is your room. Now in this room you want to, outside temperature, let's say, right, T atmospheric, right? T atmosphere is, let's say, 5 degrees centigrade. Okay, but in room you want to maintain TH value, that you want to maintain here 20 degrees centigrade. Just for example, I'm giving you. So in your room you want to maintain 20 degrees centigrade because of winter situation. Outside temperature is 5 degree temperature. To maintain this temperature, you need to supply some amount of heat, QH. So the amount of heat you are supplying, that is called as what? Heating effect. That is called as heat. Now the device which is used for this, it is a cyclic device continuously, and this device will take heat from atmosphere, right? This will take heat from atmosphere and then will supply here some work, and finally it will supply the heat to the higher temperature. This is called as heat pump. So basically if you look at this device and this device look like same, actually it is same only. It is like same device can be, right, same device can be used for as refrigerator or heat pump. Same device can be used for refrigerator as well as heat pump. There is no any problem, right? Now the COP of heat pump, only the difference is our consideration, right? If you are considering lower temperature as a system, then it is called as refrigerator. Higher temperature as a system, higher temperature is desired temperature, then it is called as heat pump. So this value will come heating effect by W input, or I can say QH by QH minus QL. Now this formula is valid for reversible as well as irreversible both. So this is also valid for reversible and irreversible. This is also valid for reversible and irreversible. This is also valid for reversible and irreversible. Is it clear, everyone? So now I hope that you are very much clear that what is the second law of thermodynamics for cycle. Means complete conversion of low grade energy into high grade energy not possible. Kelvin-Planck statement, Clausius statement, heat engine, refrigerator and heat pump. I hope that you people are clear with this. Anyone have any problem up to here? Just let me know. No problem. Okay. Now coming to the point like Carnot theorem, right? Carnot theorem. Please listen here carefully. So basically what happened, right? Basically what happened, first law of thermodynamics is say, like here if you see now, right? Here if you see that, see, QR cannot be 0. Please listen here carefully. QR cannot be 0, right? Because if QR will be 0, then it is not possible as per the Kelvin-Planck. As per the Kelvin-Planck, if QR value will be 0, then it is not possible. Means efficiency value cannot be 1. Efficiency value cannot be 1, right? Efficiency value cannot be 1. So now question is coming like, what is the maximum possible efficiency? Question is coming like, what is the maximum possible efficiency? Correct? Maximum possible efficiency. So it is actually given by none other than Carnot, Nicholas Sadi Carnot, right? So Sadi Carnot, Nicholas Sadi Carnot, what he told that? He told that, please listen here carefully, he told that various engine working between same temperature limit, various engines working between same temperature limit, none has efficiency greater than reversible cycle efficiency. Means if you have engine A and if engine B, if you have engine A and engine B, both are working between same temperature limits, means higher temperature same, lower temperature same. Let's say A is a reversible engine, B is an irreversible engine. So A will have the maximum possible efficiency. A will have the maximum possible efficiency. So A will have the maximum efficiency. Is it clear, everyone? Right? A have the maximum efficiency. There is no problem because it is a reversible. And another statement what he given, that he told that the efficiency of reversible engine, is only and only depend upon the temperature limit. The efficiency of reversible engine is only and only depend upon the temperature limit. It does not depends upon how, the like how the system is achieved, whether it is a material dependency or working fluid dependency, that is not there. Means the efficiency of reversible cycle only depend upon the temperature limit. It's not depend upon the type of working fluid. And one more important point he told, that see what is the maximum efficiency for given temperature limit, that is reversible engine efficiency. And he told that for given temperature limit, maximum efficiency is reversible efficiency, right? Maximum efficiency is reversible efficiency. And he told that my cycle is a reversible cycle. My cycle means Carnot cycle, right? So my cycle is a reversible cycle, means Carnot efficiency, right? What is my another point also I would like to share here, that reversible engine efficiency is only and only function of temperature only. Efficiency is only and only depend upon the temperature. It does not depends upon any other thing, right? Now according to Carnot, his cycle, the cycle which he made, that is basically a reversible cycle, something like this, right? So this is TS diagram, PV diagram, and here 1 to 2 is reversible adiabatic compression, 2 to 3 is isothermal, TH is equal to constant, isothermal heat addition, right? This is 3 to 4 is adiabatic, this is also adiabatic, this is also adiabatic, PV to the power gamma is equal to constant. So 1 to 2 is reversible adiabatic compression, 2 to 3 is isothermal heat addition, 3 to 4 is reversible adiabatic expansion, and 4 to 1 is isothermal heat rejection. So this is the cycle basically, and this is the ideal cycle, right? Because frictionless, right? Here all the processes are basically frictionless, and you also know that frictionless cycle is not possible. It is not possible to construct any cycle which is perfectly frictionless, not possible. Clear this point? So frictionless cycle is basically not possible, right? So it, and one another point is also there, right? See here adiabatic like there are 2 adiabatic processes and 2 isothermal processes, right? Adiabatic is very fast process. See, for example, here some candle is burning, for example, and if I do my hand like this fast, then I will not feel heat. Why? Because it is adiabatic process. I'm not, process should be so fast, so that there is no time for heat transfer. That is basically called as what? Adiabatic process. So adiabatic is very fast process, whereas isothermal is very slow process. and the combination of these two processes are not possible. It is not like one process very slow, one process very fast. That is not feasible. Okay, so that's why practically Carnot cycle is not possible, but it is basically a I can say ideal cycle, reversible cycle, which is used to compare the other cycles. Clear? Okay. Now coming to the another very important point, that is Clausius theorem. I'm not going to derive here, right? I'm not going to derive. We have already did the derivation during our classes, but here it is not required at all. It is not required at all. Okay. Now, so what is the Clausius inequality? Clausius theorem. Directly answer, because it is a theorem. So theorem can be proved. Law cannot be proved. Law cannot be proved, but theorem can be proved, right? A theorem can be proved. Okay. So as per the Clausius, cyclic summation of dq by t, cyclic summation of dq by t is less than or equal to 0. This is basically called as Clausius inequality, and that is basically Clausius inequality, and this is also called as second law of theorem, right? Second law of thermodynamics, second law of thermodynamics for a cycle. Now please listen here carefully. Please listen here carefully. As I told you that second law will tell you whether the process is possible or not. Second law of thermodynamics will tell you whether the process is possible or not. Second law of thermodynamics will tell you whether the process is possible or not. Right? Second law of thermodynamics will tell you whether the process is possible or not. Right? This is the how. Suppose some cycle is there, some cyclic device is there. Let's say this is a cyclic device. Now I want to check whether it is a possible or not. Whether it is a possible or not. So what I will do here, right? Please listen here. What I will do, right? What I will do, I will directly calculate a cyclic summation of dq by t. No need to do anything, right? If cyclic summation of dq by t value equals to 0, then it is a reversible cycle. Possible but in ideal condition. Possible but ideal condition means frictionless system. If you are able to make a frictionless system, then only it is possible. Next one is coming, if cyclic summation of dq by t is less than 0, then it is irreversible cycle. Irreversible cycle. And if in any case cyclic summation of dq by t is greater than 0, means positive, then it is not possible. Then it is not possible. Then it is not possible. Is it clear to everyone? Is it clear to everyone? Right? I hope it is very much clear to you guys. It is very much clear to you guys. Okay. Now let me give you some examples here. For example, we have reversible heat engine. Reversible heat engine, right? Reversible heat engine. So for reversible heat engine, I can say that we have one source, two source. I am taking some amount of heat, let's say Q in, okay, and or QH will be better. QH, and this is the engine. It is producing work, and then it is rejecting QR to the TL. Now W is equal to, we know that is Q in minus QR. Any problem? No problem. It is the first law of thermodynamics. Now it is a reversible engine, right? Reversible heat engine. So if I consider engine as a system, if I consider here the engine as a system, this is our system, for example, right? Now apply second law. Second law for reversible engine. So if you apply second law for reversible engine, that is nothing but cyclic summation of dq by t is less than or equal to 0, because reversible, for reversible it is equals to 0, means here QH is entering. QH is entering at TS temperature minus QL is leaving at TL temperature equals to 0. Or I can say that QL by QH is equal to TL by TH. That is, let's say, equation number 1. Now efficiency is equal to what? 1 minus QL by QH. Now this particular equation is valid for reversible, valid for reversible as well as irreversible cycle. Right, but in place of QL by QH, if I write TL by TH, so efficiency value will come 1 minus TL by TH. Right, that is a valid for reversible cycle. Valid for reversible cycle. Is it clear to everyone? Right. Now similarly, you know, similarly, if I talk about, then COP, we have already in COP of refrigeration is, that is QL by QH minus QL. That is for both. That is valid for reversible as well as irreversible. But in place of QL by QH, if I write TL by TH, then COP of refrigerator value will come, that is TL by TH minus TL. That is for reversible. Similarly, if I write here the COP of heat pump is equal to QH by QH minus QL, or I can write COP of heat pump is TH by TH minus TL. This is for reversible only. This is for both. So like that you can understand, right? So okay, very good. Life Lowell, Life Love I-20. Very good, Sujay. Sujay is coming here for revision. Okay, so for Sujay there is one question, not only for Sujay, this question is for everyone. Please try to solve this. Please try to solve this. Everyone, including Sujay, Life Love I-20, Madhavan, Karthik, Laurel, Tanisha, Shreya, Ananya, Alia, Deepika, Katrina, or Katrina. Please solve, everyone. So an office uses a heat pump that receives 500 kilojoule per day heat, right, in winter to maintain its temperature 300 Kelvin. Okay, so like office is going to maintain, let's say this is an office, right? This is an office. This is the office which is maintained at 300 Kelvin. Okay, now office is a heat pump to receive 300. Okay, maintain. The ambient temperature is 280 and the COP of heat pump is 60. Okay, now so here how much heat we are supplying here? the amount of heat that we are supplying, QH value is 500 kilojoule per day, right? Through which? Through a heat pump. Now heat pump is taking heat from surrounding, right? Surrounding, that is at 280 Kelvin, right? And here obviously some work input is there, right? W input. The actual COP is actual is 60% of theoretical. Theoretical means reversible. COP reversible, right? Actual input, theoretical. Okay. Now maximum value. Okay. The ratio of actual work input to the minimum theoretical work input. Actual work input to the theoretical work input you need to find out. It is very easy, right? Okay, very good. So now please listen here. Actual work, like actual COP is what? Actual COP means QH by actual work. QH by the, right, is equal to 0.6 times of COP or reversible is QH. QH is same for both, right? Divided by W reversible. So QH is going to be cancel out. They will not required, I think so, right? And we need to find out the ratio of actual work to the minimum. Okay, so W actual by W reversible value, if you calculate, then it will come 1.0.6. That is equals to, where is my calculator? Where is my calculator? 1 by 0.6. So this value will come 1.667. This is going to be your. Now moving to the next problem. Wow, what a beautiful problem. When problem seems like big, then I am very much happy. So everyone try this. Okay, shall I go out of the frame? Okay, I'll go out of the frame. Now please try. Now please try to solve by your own. Everyone please try to solve this. Oh, very good. So here it is given that a heat engine. Oh, it's heavily raining in Lucknow. It is heavily raining, right? It is raining outside. Wow, maja aa gaya, right? So a heat engine receive heat at 1000 Kelvin and reject to the environment at 300 Kelvin, right? Okay. The efficiency of the heat engine is half of the efficiency of Carnot operating between the, okay, heat engine receive heat at 1000 Kelvin and reject heat at the environment 300 Kelvin. The efficiency of the heat engine, half of the efficiency of Carnot operating between the above mentioned temperature limit. The work output from the engine is completely used to drive a refrigerator that is steadily remove the heat from the cold space to. Okay, so let me draw the diagram. So we have one heat engine, my dear student friends, that is operating between 1000 Kelvin. Power is gone. Right, okay, no problem. When the this raining start na, then this electrical department is very happy. Now we'll cut the power. So once raining start, immediately they cut the power. So let me write here Q1 and Q2, and whatever work is going to be produced, that is going to run a refrigerator, right? This is the only mention, right? That is going to run a refrigerator. The work output of the heat engine completely used to drive a refrigerator that is steadily remove the heat from the cold 260 Kelvin. So this is basically 260 Kelvin, that is Q3 to the Q4 at what temperature? At the rate of 5.2 kilowatt, right? So this value is 5.2 kilowatt and reject the heat to the same environment 300 Kelvin. Okay, so this is 300 Kelvin. The COP of refrigerator, half of the okay, both have cases, half of the COP refrigerator operating in the same temperature limits as the refrigerator. Then the rate of heat supplied to the heat engine. So what they are asking, basically what they are asking, Q1 value they are asking. What is the value of Q1? What is the value of Q1, right? Okay, right, okay, Q1, right? So now please listen here carefully. So efficiency value is how much? Efficiency, right? Actual efficiency, if I talk about actual efficiency, that is nothing but 1 minus Q2 by Q1, and that is basically 50% of half of ideal one, means 1 minus 300 by 1000. 300 by 1000. So what is Q2 value from here in terms of Q1? We need to find out, right? What is the value of Q2 in terms of Q1, right? So I'll write here 300 by 1000, 1 minus answer. So the efficiency will come like 0.2, 0.35, right? So 0.35, this will go this side, this will go this side, so 1 minus. So this value will come, Q2 value is 0.65 times of Q1, that is equation number 1. Correct? Okay. Now W value is, W is equal to Q1 minus Q2, or I can write Q4 minus Q3, same, right? Means whatever work is produced by the engine, whatever work is produced by the engine, same amount of work is going to be consumed by the refrigerator. Now what is the COP of refrigerator? COP actual I am talking about. COP actual value will come how much? That is Q3 by W input W, that can be written as T3 by W, or I can write here Q4 minus Q, so that you will not confuse. That is equals to T3 by 50% of ideal, means 0.5 times of ideal. Ideal means 260 by 300 minus 260. Now please try to understand, right? This can be written as Q3 by Q4 minus Q3. Q4 minus Q3 can be written as Q1 minus Q2. So this is Q1 minus Q2 is equal to, so this is 300 minus 260, 260 divided by, sir, 6.5, right? So this value will come 3.25. Now Q3 value is given 5.2 kilowatt. Divided by Q1 value, we need to find out. Q2 can be written as 0.65 Q1, that is equals to 3.25. This will go this side, so I can write here 5.2 divided by 3.25 is equal to 1 minus 0.65 0.35 0.35 Q1. So from here Q1 value that we have to calculate 5.2. So this value will come 4.57 kilowatt. So whoever have given this particular answer, that is 100% correct, right? So okay, now coming to the, okay, this is all about today's lecture, right? So in second law of thermodynamics, majorly questions are going to be based on only heat engine, refrigerator and heat pump, right? And here we have solved some problems remaining. You, and for this chapter I would say, if you want to, if you want to get excellence in this particular chapter, see, conceptually it is very simple. Only you need to solve like, if you solve the unsolved question of PK, then it will be great for you. Okay. By the way, this is my telegram address, Shivam Sir Physics Wallah. You can scan it also, or you can search in a telegram. I will be there. If you feel any doubt, any problem, you can ask me. Sir, you have any project idea? Okay, you can message me in this telegram, because here if I discuss, it will be waste of time for others. So if you need any help, then you can ask me in the telegram. Okay. Sir, will the updated syllabus? Yes, definitely it will be covered, but I would like to tell you, there is no any change in basic thermodynamics. There is no any change in basic thermodynamics part, so there is no problem at all, right? Sir, you have any mechanical project? I told you na, right? I told you that you ask me in telegram, I will reply, because here if I talk about the project and all, it will be waste of time for others. Okay, so you ask me in telegram, right? DM, you can DM also. Anything else? Okay, so I hope it is very much clear to you. Thank you very much. Let's meet tomorrow, and tomorrow we'll discuss the most interesting chapter, that is entropy. Let's meet tomorrow.